Okay, let's talk about, oh wow, you put a 2 up there. Let's talk about volumes of pyramids and cones. Okay, remember, this is a pyramid right here. It's a pyramid. This is a regular pyramid, okay? It's regular because its base is a square, which is a regular polygon. It is a right regular pyramid. Why? Because the vertex is over the center of the base. And when I connect the vertex to the base, I get a perpendicular height, or the perpendicular distance between the vertex and the base, and it's in the center of it. Okay, so that's this. Remember, there's a vertex where all the lateral sides come together at one point. Cone, same way, except the base is a circle. I have a vertex, okay, where that all comes together at the top, and then if I connect this, if I have a right cone, then the vertex will be perpendicular to the center of the base. So let's look at this in definitions. For pyramids and cones, the volume is base times the height divided by 3. Or if you prefer, 1/3 base height. Where B is again the area of one base. H again is the height or the altitude. It's a perpendicular distance between the vertex and the base. Remember, perpendicular distance between the vertex, okay, of the pyramid and the base. Perpendicular distance, however we need to measure that. And for a cone, the perpendicular distance between the vertex and the base. This being the vertex, this being the base. Okay? Now, these are fairly simple, so we're going to go right directly into doing some problems. What do we need? We need a base. Area of the base. Well, this is a rectangular pyramid. It's 12 by 8. Base is pretty simple, 12 by 8. I can do that one even in my head. That's 96 foot squared. And H is the perpendicular distance between the base and the vertex. Well, they show that to be 10 foot. So the volume is simply going to be 96 feet squared times 10 foot, and that equals 960 feet cubed. Okay, a little more work, a little more what you got to do, but pretty straightforward, just like prisms and cylinders. Now let's look at this one. This one is going to be just a little bit more work. Why? Because it's a hexagonal pyramid. Our base is going to cause us a little bit of a challenge. Why? Because we have to find the base of a regular polygon. Well, if one side of that polygon is 6, we know, because it's a hexagon, that every one of those things is divided into a equilateral triangle. Let's take one of those equilateral triangles and find the apothem. We know that this is 6. This is 6. If we drop an altitude, that's going to change this into 3 and 3. I can find the apothem simply by doing Pythagorean theorem. The apothem squared equals 6 squared minus 3 squared. A squared equals 36 minus 9. A squared equals 27. A equals the square root of 27, or 5.2. So our base is going to be our regular, which is our perimeter, times our apothem divided by 2. What does that equal? Our perimeter is, how many of these do we have? P equals 36. We know what A is, so this is going to be 36 times 5.2 divided by 2 equals, let's get that, 93.6. So this is 93.6. What's our height? That we're given, which is simply 8. Okay, so our volume equals 93.6 times 8. $748.8. And what is it? Feet cubed, okay? feet cubed. Okay? All right. It's 2 of them. Let's do one more and we'll be done. This one is hard to draw. Looks like a mess. It is an oblique square pyramid. That means the base is a square, which is 15 by 15. It's oblique because from the front, it's slanted. It doesn't look like this. It's look like this on the bottom. It doesn't look like this from the top. It looked like that. It's slanted. It's not, the vertex is not perpendicular to the center of the base. Okay? So what do we got to do? Well, what's our B? Let's throw that thing away and get something else over here. See if we've got another one that's going to work for us. Okay? Ooh, that looks a lot better. Our B is simply going to be 15 times 15. I think that's 225. Check that and make sure. Oops, that was wrong. Okay. Our H, we're given that, okay, the perpendicular distance between the vertex, perpendicular distance. That's wrong. Let's get that distance in there right. Distance between the vertex and the base. Between the vertex and the base equals 16. Okay, so our volume equals 225 times 16. Okay. All right, make sure of that. Yep. And there you have pyramids, 3 different things of pyramids. This again is going to be the one that's going to cause you the most challenge. The hexagonal is much easier than most. Pretty straightforward for us to find, but you're going to need to find those. Okay? Now let's do some cones.